Hello, so we're going to do a problem today, a variation of parameters. This is problem, I think, 2 in the book. And you're going to see how just immediately it becomes a pain, okay? So we're going to take and we're going to solve y triple prime minus 2y prime, 2y double prime plus y prime equals x. Okay, so we're going to solve this problem. Okay, so let's first start by the homogeneous or the characteristic polynomial. Okay, that's easy enough. So r cubed minus 2r squared plus r equals 0. Okay, because the characteristic polynomial is something about the homogeneous equation, right? Okay, so factoring out the r squared minus 2r plus 1 equals 0. R times r minus 1 squared equals 0. Okay, so that means what is our homogeneous solution? Okay, our homogeneous solution is, well, C1 plus C2 e to the x plus C3 x e to the x. Okay, so this gives us a root r equals 0. That's the C1. And then we have a double root at 1, so that means we have e to the x and x e to the x. Okay, so let's write our set of solutions. So these are our linearly independent solutions to the homogeneous equation. Okay, so linearly independent solutions to the homogeneous equation, we have 1, okay, 1 is the, solution. So think about it. 1 solves the homogeneous equation. 1 triple prime is 0, 1 double prime is 0, 1 prime is 0. So y triple prime minus 2y double prime plus y prime equals 0. Okay. Next is e to the x. And next is x e to the x. Okay. Now let's go ahead and build our Wronskian. Okay, so the Wronskian is actually the determinant, but we'll build the matrix for the Wronskian. Let's call it little w. Okay, so little w is going to be 1 e to the x, x e to the x. Let me move this a little bit away from there. Okay, next, the next line, the next row, okay, remember in the Wronskian, is the row of determinants. Okay, so the determinant, of derivatives. The derivative is, well, the derivative of 1 is 0. Derivative of e to the x is e to the x. And the derivative of x e to the x is actually x e to the x plus e to the x. No, I did not use a computer algebra system to calculate that derivative. Shame on you for thinking that, okay? The next line is going to be the second derivatives, okay? The second derivatives is going to be 0 e to the x e to the x plus 2 e to the x, okay? All right, so this is our Wronskian, okay? Now, what we're solving in terms of the system is the system we're solving is we're solving for the v1 prime, v2 prime, v3 prime. So we're solving Why do I do this to myself? This is our matrix. I'm thinking I'm going to try to get iPad to sponsor me because I'm showing you guys how to use this thing. I don't know. I would never use another thing to do math again. Okay, so this is the matrix we're going to solve. This is this system right here. Okay, so the matrix with all the y's and y primes, y double primes up to yn minus 1, the v1 primes, and then this is the system of the forcing function. Okay, forcing function here is x. Okay, now I'm going to show you what to do. Okay, I'm going to show you what to do, and then I did the calculations in Sage, okay, so that you can see how to do that. Okay, and I'm going to post the Sage notebook also with the notes so that you can have it and you can see how it works and you can use it as well. Okay, you can play with it to, well, if I post it, I don't think you'll, but you can sort of see and build off of that to do the same similar problems. Okay, so what is the solution? Okay, well, we need to find v1 prime is going to be the determinant of, remember, we're replacing this first column by 0, 0, x. Let's call that's the Wronskian. So the determinant of, let me copy this. Okay, so that's the first V, that's the V1 prime. V2 prime is going to be the determinant of, now instead of this, so while I'm doing this, I want you to think, what column am I going to replace on this matrix in order to get V2 prime? So, okay, I want you to say it out loud. That's right, we're going to replace the second column. So we're going to replace the second column by 0, 0, x. Okay, running out of space. Not a problem. Okay, then V3 prime is going to be the determinant of now, which column now? We're going to replace exactly the third column with 0, 0, x. Okay. Now, our solution, our actual solution, is going to be yp of x, or actually particular solution is going to be v1 of x, y1 of x, plus v2 of x, y2 of x, plus v3 of x, y3 of x. Okay, so let's go ahead. We're going to go ahead and move over to Sage now. Okay, so you have everything written down? All right, I'm going to change the screen now. Okay, so here is, I've already set it up. Okay, so let's set up the Wronskian. So what did I do first? I set up a variable x. I set my matrix. This is my W matrix that I was calling. Okay, I can actually show it too, so you can see what it looks like. Just to check, make sure it's the right matrix. I'm looking at my paper. That, yes, that is the right matrix. Okay. Then I have M1, M2, and M3. Okay, I even called them that in the notes. Okay, I'm going to show them so that we can see. Okay, those look right. Okay, now, so let's see. So this is just a notation. You see, I created the matrix. I basically just copied and pasted and replaced the zeros where I needed to. Okay, or replaced the columns. Next, I apply Cramer's rule. Okay, so when I apply Cramer's rule, I'm taking the determinant of M1 divided by W, the determinant of M2 divided by W, and the determinant of M3 divided by W. Here I had to use simplify, because look what happened when I didn't use simplify. I'll show you one of them. Okay, so I see that that's probably going to simplify, so I go ahead and use that function. That's just a function that does exactly what it says it does. Simplifies. Don't ask me why it doesn't do it automatically. You would think it does it automatically, but who knows? Okay, so now that's V1P, that's V1 prime, V2 prime, V3 prime. Now, I can do all of those integrals. V1 prime, easy. V1 is x squared over 2. I didn't even think about that one. V2 prime, that's going to be in a couple integration by parts. Since I'm already in my computer algebra system, I just said, screw it, let's do it. So I did the integrals as well. Okay, so in your notes, I want you to write down V1 is x. V2 is negative x squared plus x times e to the negative x. And V3 is x e to the negative x. Okay. No, why? Oh, okay, yeah. Sorry. That's V, those are the primes. V1 is x squared over 2. V2 is this, which, let me simplify that, because that's also, I can tell that's being simplified. Okay, so x squared plus 3x plus 3 times e to the negative x. Okay, so we've got these things. Okay, let me write them down myself. So V1 is x squared over 2. V2 is x squared plus 3x plus 3 e to the negative x. And V3 is negative x plus 1 e to the negative x. Okay, so I'm going to go back now to the notes. Okay, so my total solution, let's write it down here somewhere. So my total solution is going to be, write it in blue, y of x equals C1 plus C2 e to the x plus C3 x e to the x. So the C1, C2, C3, those would be solved by any initial conditions, right? We'd need to have 3 of them. plus our particular solution. So our particular solution, V1, I wrote down is x squared over 2, and that goes, and that multiplies on the 1. Okay, so this is our V1 of x. Okay, plus our V2 was x squared plus 3x plus 3 e to the negative x, okay, but e to the negative x multiplies with e to the x to become 1. So this is our V2 y2, okay, plus our V3 was negative x plus 1 times e to the negative x, okay, and that's multiplied by x e to the x. So there's going to be an x, and that is our V3 times y3. Okay, so I know that's a little bit of an involved problem, but you know, using the tools that are available to us, we can actually do this pretty well. Okay, all right, I'll see you all in the next set of videos.